Okay, these notes are for doing that Trig applications worksheet. These are all going to be application problems, so they're a little bit different. We'll go through the steps. We're going to work through this first one on this Ferris wheel problem. So on any word problem like this, the first thing you want to do is read through it. So this is a Ferris wheel, so think about going around on a Ferris wheel. So here's our Ferris wheel. You're going around on the Ferris wheel. They're plotting your distance from the ground. It says that varies sinusoidally with time. Now remember, the sinusoidally just means this is going to be a sine or a cosine curve. We're actually going to do every one of these with cosine. Don't do them with sine. They're much easier with cosine, twice. They're easier with what we're going to do now, and they're easier with something that will come later to use cosine. So even though it says sinusoidally, we're going to use cosine for this. Now you want to read through it. So as we're plotting their position, it says the number of seconds have elapsed since the Ferris wheel started. It talks about the seconds. It talks about your height above the ground. So we want to graph this. Now the first thing you graph is decide which two things you're graphing. Well, it talked about seconds, so that's time. Time almost always goes on the bottom. So we're going to put time down here on the bottom in seconds. You always want to label your axes. Then we're doing our height above the ground. So the vertical axis here, that's going to be height, and we're measuring that in feet. So that's the first thing, is decide what two things you're graphing. So height and time. Right? The next thing is your scale. Well, if you look at your time, we have 3 seconds, we have 8 seconds. So that's not going to be a lot. We can go 1 second each space. So if we start with 0, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you want to label that so you know what we're talking about there. Now vertically, I see a 43 feet. Well, that's a lot of feet. We don't have that many spaces, so we're going to have to adjust our scale. You can do it definitely, but I think it'll just fit on this one if I go 2 seconds each. So I'm sorry, 2 feet each. So if I go up, there's 2, 4, 6, 8, 10, 2, 4, 6, 8, 20, 2, 4, 6, 8, 30, 2, 4, 6, 8, 40, 42, 44. So we just made enough room there. So we label our sides. Okay? Now we're ready to start graphing. In this problem, they gave us a point. We just have to find it. Notice it said here, at 3 seconds, we're at the top, 43 feet above the ground. That's a point. When time is 3, our height is 43. So if we go over to time 3, so at 3 seconds, if I go up to 40, 42, 43 would be right here. That's a point on our graph, 343. And I think it's a good idea to label that because you will need those numbers later, so you want to see them. So in every single problem, they gave us a point. To me, that's giving us one, 343, okay? Then there's a second point in there. Sometimes they'll just give it to you. Sometimes you have to find it. In this one, we kind of have to find it. Because notice it says it makes a revolution once every 8 seconds. So imagine you're on that Ferris wheel. At 3 seconds, you're on top of the Ferris wheel, 43 feet above the ground. If it makes another revolution every 8 seconds, if we go over 8 seconds, wouldn't we be back on top of the Ferris wheel again if it's one revolution every 8 seconds? So if at 3 we're at 43, if we go over to 11, 8 seconds later, we should be back on top again. So here at 11, we should be back up at 43. And think of riding that Ferris wheel. You're up on the top at 3 seconds. It goes around 8 seconds. You should be back on top. So at 11, you're at 43. So there's the 2 points that they gave us that we have from there. Now we can finish our graph from that and one other piece of information in there. Now, if you think about this, here we're on top of the parabola, on top of the Ferris wheel. So those are the top of our parabola. Those are the top of our cosine curve. So those are our crests. So we're on top, so there's a crest at 343, there's another crest at 1143. Now what we need to figure out then is where's a trough at? Well, if you think about it, wouldn't the trough be right in the middle between 3 and 11? Well, if you think about it, right in the middle between 3 and 11 is 7, or if it takes 8 seconds to go around once, wouldn't it take 4 seconds to get to the bottom? So 4 seconds to get to the bottom and 4 more seconds back to the top. So that means we're going to go to 7 seconds. That's 4 seconds later. Now notice it says the diameter of the wheel is 40. Well, if the top is 43, so if here on the top of the wheel we're at 43 and the wheel is 40, wouldn't the bottom be 3? So that's our trough. At 7, we're at 3. So there's our 3 points. We have 2 crests and a trough. That's all we need. We could make a rough sketch of our parabola. It's going to look something like this. Not exactly, but it's going to look something like this. If we sketched our path on that Ferris wheel, that's what it would look like. Keep calling it a parabola. Sorry, it's not a parabola. That's all we need for equation. Okay? Now, we're going to take what we have there and we're going to find our equation. If you remember, our equation is y equals our amplitude. Remember I said we're always going to do cosine. And then times the angular velocity times x minus our horizontal shift plus our vertical shift. We're going to find those 4 things and put them on our graph. Now, in your notes packet, these equations are all in there. Let's start with amplitude. To find amplitude, you can take max minus min divided by 2. That should be in your note sheet. I'll write it down here. Amplitude equals max minus min divided by 2. Well, our maximum was 43. Our minimum was 3. That's 40 divided by 2. So our amplitude's 20. So we start our equation. We can say y equals, or if you want instead of y, you could say our height. So h equals, our amplitude is 20. We're going to use cosine. Now our angular velocity. Now just like we did on the second part of that sine cosine worksheet, to find the angular velocity, you can take the normal period, which is 2 pi, divided by the period. So here we're going to take 2 pi. Now our period, remember it said each revolution is 8 seconds. That means 8 seconds is our period. So crest to crest is a good way to see period. Crest to crest is 1 period, or trough to trough. Well, crest to crest is 8, so 2 pi divided by 8. We can simplify that a little bit to pi over 4. So I'm going to put a parenthesis here, and then excuse me, and then another one, and pi over 4. Now we need another parenthesis. Now we need x minus h. Now the horizontal shift is really easy. I think it's one of the easiest things to figure here. This is one of the things that makes cosine easier to use. Remember, cosine starts with an amplitude, starts with a crest. So notice, if I go over 3 seconds, we have a crest right there. So the horizontal shift is how far over you go before you come to a crest. So here our horizontal shift is 3. So we're going to put a 3 in there. Now all that's left is our vertical shift. Well, vertical shift is max plus min divided by 2. So here that's 43 plus 3 divided by 2, which is 46 over 2. So our vertical shift is 23. So there's our equation. We just came up with an equation to describe the motion, the height of that, you're right on that Ferris wheel opposed to time. So there was our amplitude. That was from max minus min divided by 2 was 20. For our angular velocity, we took 2 pi divided by the period, so 2 pi divided by 8, reduced to pi over 4. Our horizontal shift was 3, because if we go over on a graph from the beginning, at 3 seconds was a crest, so horizontal shift was 3. Then our vertical shift, we took max plus min, so 43 plus 3 divided by 2, which was 23. There's an equation for our parabola. Now, we're going to take that. Notice it goes on in this way that predicts your height above the ground at different points. Well, that height was going to come from our equations there. So what we're going to do is take that equation we just came up with down here. We're going to take that equation and we're going to plug those numbers in for x. We're going to plug them in there for that x. So on your calculator, you can see my calculator. Turn on the light. Maybe you'll see it a little easier. First of all, you want to make sure your mode is radians. All of these will be in radians. So here my mode is radians, so I'm good there. Every one of these is radians. Again, if you don't see a degree symbol, and you have to be careful, one of these application problems has degrees, but it's temperature degrees, not angle degrees. So we're going to put that in here. So we're going to go 20 cosine. I'm going to start with the parentheses. Then I want pi divided by 4. So I'm going to put, I got two parentheses. So pi divided by 4. I'm going to close the one for the pi over 4. I'm going to start another one. Now for x minus 3, I'm going to put 6 minus 3 and close again. So just like when I wrote that equation on my paper, I had all those parentheses in there, and then plus 23. So I just took that equation, I entered it in there like that. Now I hit enter, and it says 8.86. So what that means is, when it said find the height at 6 seconds, well, at 6 seconds, it's going to be 8.86 feet. If you look at our graph, just to see how accurate our graph is here, notice that and it doesn't have to be super accurate, but here's 6 seconds right here. Here ours looks like it's somewhere between 4 and, depending on how we made it. So we're in the general vicinity here. So that's the answer to the first one there at 6 seconds. We're at 8.86 feet. We do the same for the next one, where it says 4 1/3. What you can do on your calculator is if you hit second entry, if you can see that, if you hit second and then entry, which is the enter key, it'll bring that right back to you. Well, so I can go up if I wanted to here, instead of, and it might erase part of it. Say I'm going to delete that 6, and I'm going to hit second, and then above the delete it says insert. Notice my cursor changed. For 4 1/3, I'm going to enter 13 thirds. 13 divided by 3. So you see now I have in there 13 thirds minus 3, and I can hit enter again. That'll tell me that's at 33 feet. So if you want to do a whole bunch of those, if you hit second, so you hit second up here. So if I hit second, and then down here hit the enter button, because above enter it says entry, it'll bring your last thing back up to you, and you can just go up here and you can delete what you put in here. So I delete all that. Then you want to hit second insert, like the next one is 9, so I can insert a 9 and hit enter, and it'll just tell you the answers just like that. So on that sheet, that's what you're going to do on every problem. So you're going to look at it, you're going to graph it, you're going to find our equation, and then it's going to ask you to plug in some numbers. Now on each one of them, the very last letter, like on this one, it's letter E. We are not going to do that right now because we'll learn how to do that later. So on each one, like on 1 it's E, on 2 it's letter D, on 3 it's letter D, on 4 it's letter D. So the last letter we're going to save for later. And that's it.